Page 340, number 4, lesson 6-2. Clyde is baking and the recipe requires 1 1/3 cup of flour. Clyde has 2 cups of flour, but he is doubling the recipe to make twice as much as needed. How much more flour does Clyde need? So what we want to do first is identify what the question is asking us for. It wants us to know how much more flour Clyde needs, and we're measuring that in cups of flour. He already has 2 cups of flour. He's going to be doubling the recipe, and the regular recipe requires 1 1/3 cups. So part A, write an equation to represent the problem. Let C represent the amount of flour Clyde needs. So we know that the recipe requires 1 1/3 cups of flour, but Clyde is going to be doubling that. So doubling means that he's going to need twice what the recipe calls for. So on one side of our equation, because that is what the recipe needs and that is the goal, we're going to be taking 1 1/3 and we're going to be doubling it. So doubling means multiplying by 2. So we can show that by putting parentheses around the 1 1/3 and a 2 outside. When you don't see an operation between a set of parentheses and a number in algebra, the default operation is multiplication. So this is what he needs. Now he has 2 cups of flour, and it's telling us that how much more flour does Clyde need. So we know that 2 cups is not enough. And as we can see down here, by doubling the recipe, he's going to need more than 2 cups. But he has 2 cups of flour already, so he's going to have some more added to that. And so we're going to call the number of cups that he needs to get to this doubling amount C, because C can stand for cups. So all they want here is an equation. Let C represent the amount of flour Clyde needs. So there it is. This is his 2 cups he already has. This is what he's going to need to be able to double the quantity that the recipe calls for. Solve the equation. Well, because this is in mixed number form, I'm going to change it to improper fraction form. So it's going to be 4/3, and this is 2, and that's actually can be written as 2/1 is equal to 2 plus C. When I multiply straight across the top and straight across the bottom, I'm going to get 8/3. Notice I can't cross cancel anywhere to do me any good. So I'm going to have 8/3 is equal to 2 plus C. Now I know that it's always a good thing to get variables on one side and numbers on the other. So to do that, I'm going to want to not have this on the right-hand side with the C. So I'm going to subtract 2 from each side of the equation. So I'm going to rewrite up here. I've got 8/3, and I'm subtracting 2 from that, and that's equal to 2 plus C, and I'm subtracting 2 from that as well. So these are going to cancel, so I just have C on the right-hand side. Now, this is an improper fraction, so now it would be nicer if it was a mixed number, because I'm subtracting a whole number from it. So how many groups of 3 are in 8? Well, there's 2, because 2 groups of 3 is 6, and there's going to be 2 left over. So that's 2/3. 2 2/3 is equal to 8/3. And if I'm not sure I did that right, I can always go back and change the mixed number into an improper fraction. 2 times 3 is 6, plus 2 more is 8. So I do get 8/3. So now I'm subtracting 2 from 2 2/3. That's going to leave me with 2/3. So how much more flour does Clyde need? He needs 2/3 more of a cup. Number 4, we're going to want to represent this in fraction form. Don't use decimals. 4 times the number n added to 3 is 47. Write an equation that you can use. Well, here's my is, so my equal sign is my is, and I have 47 on the other side. So I've taken care of that part of the verbal phrase. 4 times a number. When I see the word unnumber, that means they want me to use a variable, and in this case they gave me the variable. They gave me n. So 4 times n, or just 4n, added to 3 is equal to 47. So 4 times n plus 3, and you could put the plus 3 over there if you want, it's commutative, equals 47. What is the number represented by n? So now I need to solve this. I want to have variables on one side and numbers on the other, so let's use our subtraction property of equality and subtract the same quantity from each side, which is going to zero out the 3's. So I'm left with 4n is equal to 44. And now I can use my division property of equality and divide both sides by 4. How do I know to divide by 4? Because I want this n all by itself, and 4 divided by 4 is 1. So that will leave me with 1n, or simply n. And 44 divided by 4 is equal to 11. Number 7. On on number 7, this one, they want you to solve the equation. I'll just write it out. 1/5 t plus 2 equals 17. And what they're doing here is, instead of doing the subtracting below the number that we want to get rid of on one side or the other, they're subtracting it horizontally. So right here, we know that we have variables on this side and numbers on the other side, so it would be nice if we didn't have that 2 there. So we're going to subtract a 2 from each side, which is the subtraction property of equality, which means that these 2 equals 0. So all I'm left with is 1/5 t, and over here 17 minus 2 is 15. So now to just get my t without this fraction in front of it, what I want to do is multiply by the reciprocal. And if I do it on one side, remember I have to do it on the other side. So the reciprocal is simply the fraction flipped upside down. So 5/1 is the reciprocal of 1/5. And the reason I want to multiply by the reciprocal is because then everything cancels. and I end up with just 1 times t, which is going to leave me just with t down here. But I also have to multiply this side by 5 over 1, which is the same as multiplying it by 5. So if that's unclear to you, you can put 15 over 1 and see that we just have 1 on as the denominator. So 15 times 5 is going to be 75 over 1 times 1, and that's equal to 75. Number 9. While shopping for clothes, Tracy spent $38 less than 3 times what Daniel spent. Write and solve an equation to find how much Daniel spent. Let X represent how much Daniel spent. So we know that Daniel is going to be equal to X. You always want to start by trying to figure out what your variable is before you start doing times this and minus that. So they're telling us, let X represent how much Daniel spent. Now, Tracy is spending $38, here's one of those words, less than 3 times what Daniel spent. Well, we know that we're going to put in X wherever we're talking about the money that Daniel spent. So Tracy spent $38 less than 3 times X, because she spent $38 less than 3 times what Daniel spent. And X is going to equal what Daniel spent. So let's use what we know about less than. When we see those words, that means we're going to take this and we're going to move it to the back of the bus. It's going to come over here after what the next expression says to do. So 38 less than 3 times what Daniel spent. So we're going to be subtracting 38 from 3 times X. So 3 times X, and then 38 from that. And that is going to be equal to what Daniel spent. Okay, so there is our equation. It says write, so we just wrote the equation, and solve an equation to find out how much Daniel spent. So this is actually 3x minus 38 equals x. So we want to just have x's all on one side, and we want to have variables, or excuse me, constants on the other. So I've got more x's on the left than I do on the right. So I'm going to subtract an x from each side so that I can just have x's on the left. And that's going to give me 2x, and minus 38 equals nothing. Well, nothing is 0. Now I've got my x's over here, so I want to not have my 38. So I'm going to add 38 to both sides, and I'm going to get that 2x is equal to, this is 0, 38. So now 2x equals 38. In order to just have my x over here, I'm going to do the opposite of whatever this operation is. And this operation is multiplication, 2 times x. So I'm going to divide each side by 2, and I'm going to get that x equals 38. Excuse me, 19. Brain dead today. X equals 19. So let's see if that checks out. If I put 19 back in for x in my original equation, I should have 19 on this side, and let's see what I get when I put 19 in for this x. Well, 19 times 3 is 57, and 57 minus 38 is 19, and 19 does equal 19. So $19 is what Daniel spent. Okay, number 10. Solve the equation 0 and 5/10 p minus 3 and 45/100 is equal to negative 1 and 2/10. When I do these kinds of equations, I don't like to use or worry about all those variables. So what I'm going to do is I am going to write the equation, and I'm going to look at the number that has the greatest number of decimal places to the right of the decimal. Well, here I have 1 digit to the right of my decimal point. Here I have 2 digits to the right of my decimal point. Here I have 1 digit to the right of my decimal point. So this one is 2. So what I'm going to do is I'm going to multiply by a factor of 10 that has 2 zeros, and that would be 100. 100 has 2 zeros. What that will allow me to do is to multiply each of these by 100 and not have any decimals in the equation. Everything else stays the same. So when I take 0 and 5/10 and I multiply that by 100, that means move the decimal point 2 places to the right. And my new decimal point is going to go there, and I have to fill that in with a 0. So this is going to change to 50p because I just multiplied this by 100. 100 times 5/10 is 50p, 5/10 p. Now if I take this times 100, I'm going to move this decimal point 2 places to the right, and I'm going to get a negative 345. And properties of equality say if I do it on the left, I have to do it on the right. So I'm going to move this decimal point 2 places to the right, and instead of having a negative 1 and 2/10, I'm going to have a negative 120. Now I can deal with all integers instead of having to deal with decimal points. So I'm going to add 345 to each side. Because that will allow me to not have numbers on the side where I have my variable. So that's going to give me 50p is going to be equal to 225. And now properties of equality say that I need to divide each side by 50 because I'm undoing the multiplication here by dividing. So divide, divide, I'm just going to get p, and when I take 225 and divide it by 50, I get 4 5/10. And that is my answer.